Okay, so I guess this is the group of people who couldn't get an early flight home. So, um, so what we're talking about today is InterSystems deployment options. Let me start off by introducing myself. My name is Ray Wright. I'm a principal technology architect at InterSystems. I've been with the company for about 22 years now. For the first 10 years or so, I was a sales engineer working at the Cambridge office here in the US. Moved back to the UK to work to be the track care technical delivery manager for the first round of track care rollout in Scotland. And I've been in my current role about 7 years or so now. You may not have come across the technology architect group before, so let me just give you a little bit of background on who we are and what we do. We're a relatively small group. You've got a fair percentage of it in the room with you now already. We've got a couple of people in corporate office in Cambridge. We've got one guy on the West Coast. We've got one guy in Australia and myself in Europe, in Scotland. What we do is work with all of our products, all InterSystems products. Our role is to make sure that when the time comes to deploy your application, it's done in a way that means it's performant, scalable, and resilient. So we're thinking about the platform you're deploying on, what sort of architecture is going to support your plans to scale up as the system grows, and how you can design in high availability and disaster recovery capabilities that are going to be appropriate to meet your business requirements right from the get-go. It's not great PR, but to some extent we're the yes, but have you thought about people, right? Performance, resilience, and scalability are generally not the cool cutting edge stuff that everyone wants to be working on, and too often they're an afterthought. But they're crucial to the success of your deployment. So what I hope to do today is give you just a checklist of things to think about right from the outset, so you can design and build them into your system and your deployment right from the beginning. So, standard agenda slide. So what the title of the session is deployment options, and what I'm aiming to is pretty much what it says on the tin. Talk about the different ways that applications built within systems technology can be deployed. More importantly, the sort of things you need to consider when you plan what your deployment is going to look like. Things like what kind of application are you deploying? Are there any prerequisites or dependencies for your deployment? How do you need to scale? And how resilient do you need your application to be? In broad terms, that really means three things: what, how, and where. And by the end of the session, I hope that you'll have a better understanding of the role that those questions play in making optimal deployment choices. Because we're going to talk about these things kind of sequentially in order, I'll just pause, see if there are any questions after each section rather than waiting till the end. So please, if you do have anything, I'll ask for questions and we can, if you want to just discuss things, we're not a big group, that's good too. Okay, so let's start off with the what. It's day 3 of the conference, so I'm really hoping that this isn't a surprise to anybody, but just to recap for anyone who perhaps his attention has wandered over the last few days, InterSystems currently has 4 products. We have InterSystems Iris, Iris for Health, HealthShare, and TrackCare. InterSystems Iris is our next generation cloud-first data platform for building high-performance applications. It's optimized for data-intensive analytics, provides seamless interoperability with existing infrastructures. It's optimized for applications that simultaneously ingest data at high rates, process that data, and execute analytics across massive data sets. The database management component supports SQL and NoSQL data models and transactions at scale in a single multi-model DBMS engine. The interoperability component rapidly connects people, processes, and applications to eliminate data silos by providing industry-standard APIs, a library of pre-built adapters, and a comprehensive object-based toolkit for developing your own custom connectors. It also supports orchestration, monitoring, and management of synchronous and asynchronous interactions. InterSystems Iris includes powerful embedded analytics capabilities, including integrated ML to automatically create and train machine learning models, business intelligence tools for exploring and reporting on structured data, and natural language processing technology to leverage unstructured data. It's also an open analytics platform that can connect to and leverage third-party tools and standards like Apache Spark for analytics, PMML for machine learning, UEMA for natural language processing, and self-service business intelligence tools like Tableau or Microsoft Power BI. Our highly scalable healthcare data management platform, Iris for Health, builds on that interoperability technology and adds support for healthcare standards including FHIR, HL7, IHE, and other globally important information protocols and messaging formats. HealthShare is an advanced healthcare interoperability, working for the wrong company, interoperability and analytics platform. It can create a unified longitudinal care record for providers, patients, payers and government healthcare systems. It supports healthcare standards including FHIR for enhanced data sharing and analyses aggregated data to aid decision making and identify gaps in care. TrackCare, finally, the one you're probably least familiar with, is InterSystems' unified healthcare information system. It provides clinical, administrative and financial information and acts as a single source of truth for data about each patient. It offers enhanced clinical decision support capabilities and provides powerful analytics for real-time performance and patient health insights. Now, you'll have noticed when I'm going through the products that I've used a different coloured highlight for Iris and Iris for Health on one hand and HealthShare and TrackCare on the other. And that's really just to indicate or emphasise that Iris and Iris for Health are platforms for you to build your own applications. And HealthShare and TrackCare are applications that we, InterSystems, have built in-house on those platforms. As you can imagine, this differentiation between built and bought has implications for the choices you can make at deployment time. And we can think of them as steps on a continuum, from a point where you've got lots of deployment options open to you, you can choose between them, to a point where the deployment options have already been taken, already been chosen, the model is set and you're constrained to go with it when you deploy. If you're using Iris or Iris for Health for custom development to build your own application, then the full range of deployment options is available to you, at least at the design stage. Beyond that, they'll start to narrow, depending on the type of application that you plan to build. If you're deploying an application that somebody else has built, and that could be InterSystems if you're looking at HealthShare or TrackCare, or one of our application partners if you're looking at their products, then you typically have less choices to make. The application will generally have a defined reference architecture. It may only be supported on certain operating system platforms and will generally just be best suited to certain scalability models. So, for example, if you're deploying TrackCare in a hospital, it'll be on Red Hat Linux. End of story. We'll recommend an architecture that leverages InterSystems mirroring, deployed in synchronous mode for high availability, and will publish and give to you a hardware compatibility list that details the server, storage, and cloud platforms that we benchmark performance against. So a lot less to choose from. The end point of the spectrum is deploying an application that you've procured as a service. The least prescriptive model here is infrastructure as a service, which is basically just a mechanism for outsourcing the provisioning of data centers and servers to a third party, who could be a public cloud provider like AWS, Azure, or GCP, or a hosting provider like BIOS or Equinix. Either way, the infrastructure provider will just be giving you servers, storage, and network, and everything else is going to be down to you. What it does mean, though, is that you have to work within the framework that they're providing for you. So, for example, if you're deploying in an infrastructure as a service model on Microsoft Azure, you have to choose from the list of instances that they support. You have to choose between premium and ultra storage, and you have to deploy in a way that leverages their global network of availability sets, availability zones, and regions. Deploying in a platform as a service or a software as a service model is different because you've deferred most, if not all, of the deployment choices to the service provider, who will encapsulate them within the service they're providing. So, for example, if you're migrating your Health Connect deployment off-premise and into the InterSystems Health Connect cloud platform that's been talked about this week, as a service offering, there's a clearly defined deployment model. It's running in a virtual private cloud in AWS, and you develop, run, and manage your interfaces on top of that, but there's no discretion over what the actual deployment infrastructure looks like. And at the further along the spectrum, if you're using one of our new software as a service offerings, like Iris Cloud SQL, the deployment model is even further abstracted, in that case, into Kubernetes managed containers. In both these cases, the only deployment choices you'll have to make are how big you want this thing to be, like small, medium, large, and which public cloud platform you want to run the service on. Next thing to think about is really types of application. If you're building or buying an application, it's important to understand what kind of application it is or you're getting and how that's going to constrain your deployment options. There's a standard way of classifying these things. It's the Gartner classification into two groups, reliable and agile applications. It's overly simplistic. Reality, it represents two ends of a spectrum rather than two different things, but it's good enough to illustrate the point that we want to consider here. So if we look first at reliable applications, the ones on the left, mode 1, reliable applications, they tend to be relatively stable, predictable performance and capacity requirements. We can plan for what we need and we know how it's going to change over time. And change tends to be incremental. We're releasing bit by bit and changing bit by bit. The cycle times for development, testing and implementation tend to be long, months or even years for very big systems. Server-side architectures for reliable applications tend to be monolithic rather than service-oriented, and they tend to be stateful, data-centric, and persistent. They're typically deployed on virtual machines or on bare metal, and health share and track care as they currently work are good examples of mode 1 or reliable applications. Plenty of good seats still available. Come on in. If we move on to agile applications, they typically have a faster rate of change. And they're typically not incremental, they're driven in response to consumer requirements. Less predictable capacity demands, less predictable functionality growth. Cycle times tend to be short, days, weeks, even hours in some cases. These are the consumer type applications, these kind of things you run on your phones for messaging your friends, ordering takeout food, or posting a picture of your trip to Seattle, which I assume we've all done. Picture of the Space Needle, I know I took one. Agile applications are typically cloud first or cloud native, and they're likely to have a service-oriented architecture and be built using a DevOps pipeline. And they're much more likely to leverage a container-based deployment than a reliable application is. Okay, so that was the kind of the what. Does anyone have any questions or comments about what before we move on to the next topic? I've got 20 minutes of material. We've got to fill it somehow. Come on. For you, Henry? For you, Henry? Nobody else, but for you, certainly. Okay. No? Okay. Ice cream quicker then. Let's hope they're serving the ice cream early. Okay. So that's what. Let's talk about how. And we really need to think about three things from a how perspective. How resilient does your system need to be? How do you need to scale? And how you deal with any constraints that the platform's going to give you. Okay. For mission critical applications, a resiliency model that supports your business needs, business requirements is absolutely non-negotiable these days. So let's start there. The resilience model needs to address two things: high availability and disaster recovery. High availability means provisioning systems that can tolerate component failure and still ensure an agreed level of operational performance. In a highly available deployment, failover happens automatically without operator intervention and there's no data loss. So really what we're protecting against here is things that we expect to fail. Okay, server goes down, you lose a network connection, that kind of thing. Okay. The availability of a complex system is typically measured in uptime. That's the percentage of time that the system has been working and available. Uptime is normally expressed as a number of nines, which is the percentage of time that we've been available. More nines means more availability, but also means more cost. Some hardware components, like your SAN, your storage array, provide uptime levels of 5 or even 6 nines. But complex real-world systems that we're going to be deploying typically operate in the 3 to 4 nines range. So the first key consideration is to understand what level of uptime your system needs to support and then architect accordingly. More nines are more expensive, so don't spend money on availability that you don't need. Outside the cloud, our typical deployment is virtualized, and hypervisors like VMware ESXi and Microsoft Hyper-V include a high availability mechanism as an integral part of the platform. If a virtual machine fails, the hypervisor will restart it, either on the same physical server or on a different physical server, depending on how the failure happened. Typically, that's going to take minutes to happen. And based on that, you'll generally be able to support 3 nines of availability. Okay. Public cloud deployments also have a built-in high availability component capability, but the mean time to restart there is typically longer and isn't part of your SLA typically. If you deploy on bare metal, on the other hand, you'll need to take care of availability yourself. Generally, you'll do that by deploying a failover cluster, and again, because of the time taken to failover between nodes, it's generally going to support 3 nines of availability. The common factor about all these things is that they're all 1x, one-time storage solutions. You have a single copy of your data, plus your backups, of course, hopefully. To move from 3 nines to 4 nines, and 4 nines is the typical requirement for in a healthcare setting, and a minimum requirement typically in a financial services setting. So to move to 4 nines, typically you're going to require a move to a model based on replication rather than redundancy. And it's going to be a 2x storage solution, so you can have 2 copies of your data. Preferred way of doing this with InterSystems technology is to implement our mirroring, InterSystems mirroring, in synchronous mode. InterSystems mirroring is a shared nothing solution, redundant compute and storage, designed to be an economical solution for rapid, reliable, robust failover between systems. A synchronous mirror set consists of 2 mirror members, connected only by a network, physically independent mirror members, no shared points of failure, connected by a network, plus a mirror arbiter to mediate the failover. Best practice recommendation is to deploy each mirror member and the arbiter in a discrete failure domain. But how you construct that failure domain, how you define that failure domain, will depend on your chosen deployment platform. For virtual deployment, it could either be separate physical servers or separate hypervisor clusters. For a cloud deployment, they could be availability sets or availability zones. And for bare metal deployments, they could have to be either physical servers or failover clusters. So as we've seen, mirroring for high availability is a capability, it's a feature that's broadly available across all our product line and can be implemented in a range of deployment settings. Next, we'll move on to disaster recovery. And here we're really talking about protecting ourselves against failures that we can't predict. Fires, floods, earthquakes, that kind of thing. Disaster recovery is the provision of additional compute, network, and storage in a geographically discrete location. For on-premise deployments, that's going to typically be a second or possibly third, depending on how you've done your HA, but another data center located far enough from the primary that it's not going to be affected by whatever events affected the primary. So if a plane crashes on the primary, you want your secondary to be far enough away that it won't be impacted. You don't want to put them in the same floodplain, that kind of things, or same earthquake zone. Okay. For a cloud deployment, you'll typically use another region, which is effectively a geographically distanced data center. Failure to DR always requires operator intervention, doesn't happen automatically, and it may incur data loss. The way we quantify these are as RTO, or recovery time objective, which is the amount of time in which your service must be restored, and RPO, which is recovery point objective, and that's the amount of data you're prepared to lose at the point of restore. And just like with high availability, reducing the time to failover and minimizing the data loss cost more money. So again, you need to decide what you need and plan and provision accordingly. The key question around DR provision is how you intend to replicate data from your production system to the disaster recovery site. There are lots of ways of doing this. Some platforms have a built-in mechanism for doing this. For example, storage level replication or virtualization. There's another one I can't say. Virtualization replication. And there are also third-party tools like Zerto that do this and add a management service type wrap around it. Deploying InterSystems mirroring in asynchronous rather than synchronous mode is also an option. And assuming that you're using synchronous mirroring for your high availability, it's got the advantage that you've got one replication mechanism to monitor and manage. As a slight digression here, can I just mention backups? Backups aren't really a deployment option. They're more of a day two operational type issue than a deployment choice. But in my day job, I see a lot of people who don't think about their backups, and it causes us no ends of problems. So while you're thinking about your deployment options, think about your backups too. Think about how you're taking them, how you're validating them, because an unvalidated backup is not worth the disk it's stored on or the tape it's stored on or whatever. How you're going to restore them, and most importantly, when you're going to restore them. Everyone needs reliable backups, but in these days of tens of terabytes of databases, restoring a backup is a non-trivial exercise. And unless someone figures out how to change the laws of physics, that's not going to be different anytime soon, right? Restoring a backup on a properly resilient production system is, generally speaking these days, a last resort in response to some sort of extreme situation. So it's important to know ahead of time what that situation might be, how you plan to respond to it. Is it, loss of your HA and your DR, then where are you going to restore it, that kind of thing? Is it a ransomware attack? How are you going to restore from that kind of thing? So those are the kind of situations we see backups being restored from. So as I say, think about what's going to trigger you restoring from a backup and how you're going to deal with that when the time comes. You don't want to be figuring that out and figuring out if your backup's suitable for it when that happens. In terms of how to do your backup, we have a backup utility. I wouldn't recommend using it for production systems these days. We don't. Our recommended solution these days is a paused external snapshot-based backup managed with a third-party tool like Veeam, NetBackup, or whatever. And you really need to keep, your three copies, 2 media, and something air-gapped, just in case things go really, really, really wrong. So I'm a sermon over about backup. Does anyone have any questions about what we were actually talking about resilience, about HA and DR?
Just for those that might not be familiar with the number of nines, just can you give a frame of reference when you're talking about 3 nines?
Three off the top of my head, 3 nines is
like 8 or 9 hours.
8 or 9 hours, and 4 nines is 10%, 80 or 90 minutes. Yeah. So that's the kind of range we're talking about, hours annually as opposed to less than an hour. Yeah.
Ray, I thought it was an interesting point that you just brought up there about backup in the context of resilience and ransomware. And I wondered, are there any special kind of considerations now that should be applied in the case of ransomware? If you see what I mean. Has it changed the approach to it? I've always thought about disaster recovery, for instance, as there's an earthquake or a plane hits the building or something like that. But ransomware is
different. Yeah. There's a lot of implications around security and how you manage your perimeter, whether you do whitelist type security or blacklist type security, whether the most effective way to protect yourself against ransomware is, it's not encryption, that doesn't help. It's monitoring your network for suspicious activity and acting upon that immediately you see it. So your backup is going to help you if you need to recover from that kind of thing, provided it's not infected, of course. And that's why you need to air gap it.
And I'm sort of wondering specifically, if somebody's got in and they're holding you to ransom, you've got a backup from yesterday, that might not help you.
Might not help you at all.
Right?
No, that's why you need to validate it. right?
So validating your backup, but also should you sort of change your strategy and having a weekly backup, a monthly backup?
That depends on your business case. What you need to do is know that you have a backup that is valid and not reachable. Not is not reachable by the ransomware, right? So, I mean, the term is air gap. Air gap just means not reachable across the network. Right? Yep. Anyone else? Okay. These are all planted questions, by the way. So what we'll talk about now is the scaling model and how you're going to scale your compute. There are basically two scaling models to think about: vertical scaling and horizontal scaling. Vertical scaling is the easiest one to get your head round. It just means adding compute resources to a single instance of InterSystems technology. So you might be deploying Iris for initially limited workload, say you're ingesting and analyzing 10 million messages a day. You figured out you need to start with, say, 4 CPUs, 32 gigabytes of RAM. As your workload increases, you monitor performance on your system. And when you reach a threshold, and we typically use 75% of resource consumption, consistent, right? Because that gives you room for bursting above that. When you reach that threshold, you plan how to add resources in increments that fit with the way you expect the system to grow. Okay, so perhaps when you get to 20 million messages a day, you need 8 CPUs and 64 gigabytes of RAM, and so on. The key to doing this properly and successfully is monitoring your system. Right? You need to monitor system utilization using our platform level tools, but you also need to monitor your key application metrics. It could be whatever drives your application. Okay? Doing those two things together will allow you to build a model that equates workload with system utilization, resource consumption, and allow you to plan for future growth. For our applications, healthcare and track care, we've already done that. We've invested, our group, technology group, invests a lot of effort in doing this, in building the initial model and then keeping it trued up with what we're seeing in the field. So we've already done that. These models are driven by key application metrics, and we'll work with someone deploying these to help size and scale their systems. So if you're deploying healthcare, for instance, we'll look for metrics like patient population, number of messages, number of documents, size of the documents that you're processing. Feed those into the model and give you a suggested architecture that will specify the amount of compute and storage resource that you're going to need. And we can also model, obviously, future requirements. If you say you're going to grow 10% over the next year, we can feed that into the model and so on. So that's great for an application that you're buying from us. For a custom development on InterSystems Iris or Iris for Health, we obviously don't have that. You're building something. We don't know how it's going to scale and behave under load. But what we do know is how to build those models. So when you're building your application, you can work with your sales engineer, and behind the sales engineer, the TA group, technology architect group, and we'll help you to look for what's important, what the key constraints are, what the key metrics are to build that model so you can have one that fits your own application. So vertical scalability for compute is easy to understand. It's a very appealing option, and it's generally going to be your first choice, but it does have limits. Sometimes the limits, the bottlenecks and thresholds are inherent in the application. You've built it so it can't process more than X number of transactions because you've got a lock contention, or you're single threading a process, or that kind of thing. So in those cases, you'll need to do code optimization, rationalization, refactoring, possibly redesign and rewriting. But sometimes the limits are constraints of the platform. The application's working fine, but you need a bigger box. Right? So you could need a bigger physical server, you could need a bigger VM, you could need a bigger instance from your chosen cloud provider. So if you think you're going to reach that point, you need to have a strategy for what you're going to do beyond there if you need to continue scaling. And at that point, you have to look at some sort of horizontal scaling, which means that instead of making a single instance bigger, you're adding more instances to do some of the work. There are basically 3 ways of doing this, and the one that you choose will be governed by a couple of things: the type of application you're running and the technology you're running it on. The options are ECP, Sharding, and Federation. And let's look at each one in a little more detail. ECP, first way to do this is using InterSystems ECP technology. ECP stands for Enterprise Cache Protocol. It's a mechanism for it's a distributed data caching protocol that manages the distribution of data and locks among a network of instances. Data and code are stored on the database server and they execute on the application server. ECP itself automatically establishes and maintains the network connections between the application servers and the database server. And if a connection is broken, ECP will automatically re-establish the connection and attempt, if it's possible, to restore the operating state of the system. ECP is a good option if you've reached the limit of vertical scalability and you need to bring more compute power to solve the problem without changing the structure of the code. Important to mention that this idea of distributed caching allows each application server to maintain its own independent working set of data in memory. So to get the best out of that, intelligent workload distribution between the application servers is key to good performance. So you need to think about how you're going to distribute your application workload between application servers to maximize the benefit of data that's cached on any one particular application server. The default mechanism for doing this is round robin. Each next connection goes to the next application server. You've used them all, you start again at the beginning. That's simple, but it's rarely the most efficient. So if you are planning an ECP deployment, one of the things you'll want to discuss with your sales engineer, with the technology architect group is, how are we going to manage the distribution of the workload across the servers? How can we identify cohorts of users, cohorts of application workload that use the same working set of data and run them together to get the most benefit out of that data caching? Key feature here is that both the distributed caching architecture and the application server tier are entirely transparent to your application code. So if you do need to move from a single instance to an ECP app server database server model, there's no code changes involved. What you're doing is changing configuration, not code at that point. So ECP, to net it out, is primarily a way of scaling for compute resource and having a single instance manage all the data access. Of course, that single data access instance could be mirrored, okay, on the back end to make it highly available. So that's highly available through replication. Your app servers are highly available through redundancy. You're typically either going to have n+1 or 2n, depending on what way you distribute your application load across the application servers. So next up, let's look at sharding, which is a horizontal scaling technology again, but it's a horizontal scaling technology that deals with data volume, not running out of compute resource. So sharding is a key feature of InterSystems Iris data platform. And what it does, it partitions data storage and caching across a number of discrete Iris server instances to provide flexible, inexpensive performance scaling for data ingestion and queries. Queries against sharded data or sharded tables run in parallel on all of the data nodes. And when they're finished, the results are merged, aggregated, and returned as a complete result set. Sharding is particularly applicable to use cases that query large data sets and or return large result sets. Use cases that run high volumes of complex queries or that ingest data at high volume and high velocity. Key point here is that a sharded architecture partitions the data across and associated indices across multiple instances, termed data nodes, while allowing applications to access all of that data through a single entry point. Queries run in parallel, as I've said, on all the data nodes, with the results automatically merged, aggregated, returned to the application as a single result set. It means that query performance against large tables is no longer constrained by the resources of a single instance, and sharding provides near linear scaling of compute and memory resource across the shards, allowing you to design a sharded cluster tailored to your workload. And obviously, You're going to start off with a number of shards. As your system continues to grow, you might need to add more, and then you're going to rebalance your data across the data shards. Okay? Important to remember, though, that sharding maintains a single copy of the data. So it's a scaling solution, not a resilience solution. The third approach to horizontal scaling is to build what's termed a federated system. And what you're doing here is taking your single application instance and decomposing it into multiple instances. Each delivers some part of the overall application functionality. So this is the approach we take with HealthShare. To deploy small systems, we have a single UCR instance, but as the workload scales up, we decompose that into separate instances. So we might have registries, edge gateways, access gateways, the IHE bus, and so on, running on their own instances. Each of these, as I said, deployed in its own instance, and each one can scale vertically independent of the others. Okay, so if your access gateway needs to be bigger than your registry, that's something you can easily do. So, does anyone have any questions about scaling?
I know. You think I do these things. So federation is the option that really requires you to make some decisions about your code and what functions where the vertical and horizontal options, you don't have to change your code.
So the key point is that the component parts of the federation need to be loosely coupled, right? And if you haven't designed your application that way, you're going to have to do some code changes. So if you think you're going to need to do that, it's one of those things that you need to bear in mind when you design the application. How am I going to, is this one great big chunk of stuff, or can I break it down into things that we can possibly break or pull apart later on? So it's key design configuration, but as David says, horizontal and vertical scaling typically don't require you to think about how your application functions internally, aside from how you distribute the workload across the app servers. Horizontal scaling using federation definitely does. Yeah.
Are there any special considerations for availability and sharded?
Well, typically if you need your shards to be highly available, each shard is mirrored. Okay. So sharding is the way to spread the workload. Mirroring is the way to make each shard highly available. So backup, backup is a good idea, yes. And it's important that, see, when you get into federated systems or horizontally scaled systems, let's say, ECP app server, database server isn't really a consideration because you don't back up the app servers, you only back up the database server because that's where the data is, right? But for these loosely coupled systems, you do need to think about how you're going to coordinate your backup, right? Because the backup only makes sense if it's a backup of everything, right? If you back up, the registry on Monday and the access gateway on Tuesday and you need to restore from them, how do you reconcile the two? So, it is something you have to think about if you're going to loosely couple or split apart your systems.
Any special considerations for backing up sharded systems? So do you back up each sharded node individually, or do you back up the entire database to one?
Well, you back up, what you want to do is back up the entire sharded database, but the data lives on different shards. So to achieve that, you have to back up each shard individually, but you have to back them up in a coordinated way so that you know that you've got point in time across the whole sharded system, rather than Monday here, Tuesday here, Wednesday here, no good to you at all if you ever need to recover from it.
So for a shard, you'd freeze like all 4 instances at the same time, snap them all.
That's what you want to do. That's absolutely what you want to do. Yes. You want some coordinated mechanism, whatever you're doing, but you want the freeze to occur at the same time across them, or as close to the same time as you can. Yep. Okay. So the last element of how that we'll talk about is the choice of platform. Back when James and I started work, the only way of doing this was deploying directly on bare metal. You had a server, you deployed your system on it, and that's what it was. We call it bare metal. More correctly, it's a single tenant physical server, has an operating system, doesn't have a hypervisor, right? This gives you direct access to the system resources, but without any sort of virtualization overhead, but no virtualization management plane either. We do still see bare metal deployments. They tend to be at the very largest customers where they want to eliminate any sort of overhead and maximize the resources available on a big physical server. Really though, the majority over the past several years, probably over the last 10 years, an overwhelming percentage of the deployments of our technology are on some sort of virtualized environment, where a hypervisor runs on top of the physical server and allows it to support multiple virtual machines by sharing resources amongst them. Hopefully this gives you more efficient resource utilization, dynamic provisioning, isolation of the virtual machine's guest operating system from the underlying hardware, portability of virtual machines between physical servers, and so on. And again, reduces your system management overhead through a single pane of glass view of the whole environment through your vSphere console and so on. There are an awful lot of hypervisors out there. We are hypervisor agnostic, although we do have opinions. We don't have requirements here. We validate our releases against processor types and operating systems, not hypervisors. Okay, but they typically run on what are called Type 1 hypervisors, bare metal hypervisors deployed directly on the physical hardware. So the hypervisor is deployed on the physical hardware, we run on top of the hypervisor. The majority of the deployments that I see are on VMware ESXi. Microsoft Hyper-V accounts for a significant but growing minority of those deployments. I see a lot more Hyper-V deployments, I think, than my colleagues, because Microsoft have a very close relationship with NHS, who are a big user of our technology in the UK. They tend to, they don't charge them for Hyper-V, so why wouldn't you use it? The rest, the things that aren't ESXi or Hyper-V, tend to be either KVM or some sort of KVM-based product, KVM being the open source hypervisor. The other place, of course, where you're very likely to be running on a hypervisor is public cloud. AWS run a hypervisor called Nitro, which is based on KVM. Azure run the very imaginatively named Azure Hypervisor, which is a stripped down and hardened version of Hyper-V, and GCP use a more or less vanilla version of KVM. Another platform choice that's really been mainstream for the past several years and is becoming more important is containers. Containers are a virtualization option, but they're a finer grained and lighter weight virtualization solution than virtual machines, because rather than having their own copy of the operating system, each container shares access to the operating system kernel of the host, whether that's a virtual machine or a bare metal server. Container, I won't go into the pluses and minuses of containers here, but they package up dependencies along with application code. They're portable, and they're the key technology behind DevOps. They are designed, containers are designed or were designed from the beginning to be ephemeral and short-lived. So they don't do storage persistence, and you have to manage that independently with a raft of third-party add-ons and tools. You're most likely to deploy containers or in containers if you're building a cloud-first application rather than a more traditional, long-running, data-centric application. So these will be the agile applications that we saw in the Gartner slide that we looked at earlier. So before I move on, does anyone have any questions about platform options? No? I'm going to run over time, so I'll go through the rest quickly. The last thing we're going to talk about is where your application is going to be deployed. And again, this is one where the answers have changed significantly over the past few years. New options becoming available, but it's fair to say that the older options are still valid if they meet your use case. At one end of the where spectrum, we have on-premise deployments in data centers that you own and manage yourself. And this used to be the way we all did it, right? It was the only way we could deploy things at scale. But running a data center is expensive and it requires a very specialized skill set. And the requirements around data centers, things like availability, security, integrity, continue to grow more complex and more regulated. So there aren't many people these days who want to be in the data center business. Most people want to get out of the data center business and concentrate on their core competencies. Right? So the first step to doing that, or your first alternative, is to go to a third-party data center or private cloud. What you're doing here is outsourcing the provision and management of the infrastructure to a third party. In some cases, you'll just be outsourcing the management of the data center, so physical security, the building, air conditioning, that kind of thing, but you'll put your own hardware in it, okay? We generally refer to that as a co-location or colo. If the third-party supplier also supplies the hardware, then that's typically referred to as a hosted data center. So you're not putting your own kit in there, they're giving you the kit as well. Depending on how those resources are exposed to you, if they're on demand, you might think of that as a private cloud rather than a hosted solution. Okay. And in all of these scenarios, there's likely to be some offer of some value-add service around patching, management, maintenance, that kind of thing, offered by the people providing the service. But the real game changer in the where discussion has been the growth of public cloud over the past several years. As we all know, the big three in the public cloud space are Amazon AWS, which is the leader by market share, Microsoft Azure, which is the fastest growing still of the major providers, leveraging a lot its integration with and expertise in Microsoft's other technologies, and Google GCP, which positions itself as the most innovative platform. In addition, there are local competitors who are very significant in some geographies. So, for example, we do a lot of business in the Far East where Alibaba and Tencent are major players. All of our products can be deployed in public cloud in an infrastructure as a service model. Okay, so you can move your workload off-prem into the cloud in an IaaS model. And what you're doing there is, Amazon or Microsoft or Google are managing effectively the servers for you. Iris and Iris for Health are also available in the AWS, Azure, and GCP marketplaces. And beyond that, as we've talked about a lot this week, InterSystems is building a portfolio of platform as a service and software as a service offerings running in public cloud. Any questions about the where? Well, moving swiftly on then. So that's kind of the question. So what does a typical deployment look like? What does it look like? What sort of architectures are we turning out for people? What sort of architectures are people looking to build themselves? Well, kind of obviously it depends, right? It depends on all the things we've already talked about. But if you were kind of to take the average, most deployments are Linux these days, okay? And of those, most of those are Red Hat, okay? We see some Windows still, but not very much. And we see some things like AIX as well, but typical 60, 70% are going to be Linux, and the overwhelming majority of those are going to be Red Hat. Cloud adoption is increasing, okay? But I don't think it's increasing uniformly around the globe. I think in the US, people are much more ready to move to the cloud than they are in the geographies typically that I work with. So in the US, cloud is always generally a first choice. In Europe, Middle East, Africa, people ask about cloud, but they're much less likely to end up deploying on the cloud. Typically, they want it as a price comparison thing. So adoption's increasing, and I expect it will increase. I think things like the supply chain crisis. If you order a server today, when are you going to get it? Sometime next year, probably. I ordered a new laptop in February. It arrived in our UK office this week. So, it's difficult to plan around that. Cloud adoption makes that easy. It's all on demand. It's all there when you need it. Containers are still a niche deployment model, But I think this is like virtualization was. You know, there's a slow uptake, but as people build new applications and they refactor, re-architect their existing applications, they're going to take more advantage of this. So I think we're kind of, we haven't, to refer back to that discussion, the presentation in the keynote the other day, as far as we're concerned, I'm not talking about the industry generally, but as far as deployments of our technology are concerned, we haven't jumped the chasm yet. We're still on this side. Do I expect us to go further than that in the next few years? Absolutely. But, you know, there's a lot of legacy technology that doesn't fit that model. And it's a slow process to move it into an architecture that does fit that model. Most systems scale vertically. The use of ECP is, it's a valid technology, it works very well, but not very many people use it. Why is that? It's because systems, servers are getting bigger, and the servers are getting bigger faster than the applications are growing to fit into them. So we typically see a kind of wave pattern of this. You know, systems get bigger, they get too big for the available hardware, we move to ECP, and then systems get bigger. The next time people refresh, it fits back on a single server. So it's a cyclical thing. At the moment, we don't see many genuine ECP applications, many genuine requirements for ECP. Now, there are reasons to use ECP for some availability and distribution scenarios, but in terms just of scalability, not very many at the moment. Everybody wants HA. Most people want 4 nines, some people want 3 nines, but the days where you could have a single server running your application, and if it went down, that was it until it got repaired, those days are gone. Minimum of 3 nines at the moment, but healthcare, most of it is 4 nines, financial services, it's all 4 nines minimum. But not everybody thinks they need DR, okay? DR's like buying insurance, right? You pay for it, but you hope you're never going to use it. Okay, and a lot of people see it as an unnecessary expense or unjustifiable expense, which it perhaps is until you need it. We had one customer recently on an island. They lost all the infrastructure services on the island. We told them to have off-island DR. They didn't do it, so they were offline for over a week until things were fixed, the infrastructure was brought back. So that's pretty much all I had to say. Just a quick recap. Decision about how best to deploy your application is going to depend on several things. It's going to depend on the software you intend to deploy, how resilient it needs to be, how you intend to scale, any constraints of the platform. We're happy to work with you. It's my job, it's David's job, it's our job to help you answer these questions. But think about it up front rather than further down the line. Next steps, well, if your flight isn't this afternoon, I guess you're grabbing an ice cream in the farewell reception. Personally, my case is just behind the curtain here, so I'm grabbing that and heading to the airport. Once we've all got back to where we live and that kind of thing, check out the session recordings. Learning.InterSystems.com that Jim was talking about this morning. Developer community, there's a lot of good discussion. That's where the reference architectures are. So if you want if you're thinking of deploying in public cloud, you've never done it before, take a look at the reference architecture, understand what the big picture looks like, but don't use that as your template. Talk to your sales engineer, talk to your technology architect, and let us help you tailor something that's appropriate for you rather than just a one-size-fits-all solution. Okay, and you can email me if you've got any questions. My contact details will be on the presentation that's downloadable from the website and that kind of thing. And other than that, thank you. Have a safe journey home, and I hope to see you next year in Miami.